So we're doing the Chapter 5 homework review. This focuses on 5.5 through 5.8. So here from the homework review section, we're going to start out with number 20. So here we want to solve the quadratic equation by completing the square. So my goal here is to try and complete the square and then go ahead and take the square root and solve and do all that stuff. So the first thing I see here is that I have a 2, and I really would like that to be a 1. So what I'm going to do is I'm going to divide the entire equation by 2, and so 0 divided by 2 is just 0. So I end up getting w squared plus w over 2 minus 7 halves equals 0. From here, I'm going to focus on my b value. My b value here is just 1/2, right? So I'm saying my b is 1/2. Another way that we could write this is as 1/2 w. So we're maybe more used to seeing it that way. So if b value is 1/2, I'm going to be doing 1/2 divided by 2, and then I'm going to square that thing. 1/2 divided by 2 is 1/4. 1/4 squared is 1/16. So that's the thing that I want. So I'm going to rewrite my equation as w squared. Actually, I'll do it in red like this. W squared plus 1/2 w plus 1/16. Keep it balanced by subtracting 1/16. And I still have this negative 7 halves equals 0. I see this chunk here, which is the chunk that I'm going to end up factoring. So again, this should be the easiest factoring of our life. Whatever the positive or negative is going to remain the same, and it's just 1/2 the b value. So if b value is 1/2, here it's going to be 1/4. So w plus 1/4 squared. And now I'm just going to combine these two things together. So, I mean, I'm just going to jump and do this. So the 1/16, I'm going to have to make the negative 7 halves look like that, so to say. So I'm going to multiply it by 8 over 8. You can also just do this on your calculator with like math frac. So this ends up coming out to be negative 55 over 16. Equals 0. From here, I'm going to go ahead and add to both sides. So I'm going to add the 55 over 16. So I get w plus 1/4 squared equals 55 over 16. Now my next move is going to be to take the square root of both sides. So now I'll have w plus 1/4 equal to plus or minus. I'm going to break this thing up. So I'm going to say root 55 on top, and then on the bottom, root 16 is just 4. It's pretty nice. And then I'm going to say, okay, I'm going to subtract my 1/4 over as my last step. So my final answer should look like w equals 1 plus or minus root 55 all over 4. If you want to keep them separated, that would be fine as well. So if you had like 1/4 plus or minus root 55 over 4, that'd be fine as well. So either one of these answers is what I'm looking for here. Any questions on 20? Perfect. Let's take a peek at 21 here. So here my goal is to write the quadratic function vertex form. So the first thing I would like to do is to think about what vertex form is. So vertex form is y equals a, and then it's x minus h squared plus k. So as I look at this problem here, it doesn't look like it's in that form. It looks like it's actually in standard form, but that's okay. I know how to go from standard form to vertex form. And the way that I'm going to do that, oh, I should have had 23 on here as well. Whoopsie. There we go, never happened. So when we're looking at this here, basically we're saying, okay, well, how do I get this into vertex form from standard form? I'm going to have to complete my square. So to complete my square, I find my b value here, which is -8. I take -8, divide it by 2, and I square it, which gives me 16. So -8 divided by 2 is -4. -4 squared is 16. So that's the thing that I want. So now I'm going to rewrite my equation as y equals x squared minus 8x. I'm going to do plus or minus 16. And I got the plus 17 hanging out on the outside. So again, the reason I'm doing plus and minus 16 is because I want to keep this thing balanced, right? This is like my clever zero here. So then I look at these three, because I just created this perfect square trinomial. This factors into x minus 4. Again, it's always just going to be 1/2 the b value. So my b value here was -8 divided by 2 is -4. That thing squared. And now on the outside, what are these chunks left? Well, it's just going to be +1. So this is my final equation in terms of like vertex form. And then it says identify the vertex. So the vertex here is going to look like the opposite of this side. So the vertex here is going to be 4, comma, and then whatever the k is just 1. So again, this is the tricky one. The h value always throws people off because it looks negative, but actually is positive because it's x minus h. And that's it for the first one. Any questions here? Perfect. All right. That was for 21. So now what I'm going to do is go through and I'm going to do for 23. 23 is a little bit trickier just because we have a 4 out in front here. We want to be careful with how we deal with that. So let's start it off. Same goal here. So I'm just going to write this for x squared plus 16x. And I'm going to leave a big space. I'm just going to put the plus 23 hanging out on the outside because I basically want to ignore this thing, right? So as I look at these, I want the a value to be 1. Well, what do I have to factor out to make this a value to complete the square 1? I have to factor out a 4. So my first step here is to make this thing look like 4 times, and now I've got x squared plus 4x. And again, I'm going to leave like a big space, obnoxiously large, but you'll see why in a second. And then my plus 23 is still just hanging out. And I've got y equals. So the only thing I did was I changed this to look like this. And now I'm leaving a big space. And the reason I'm leaving a big space is that when I complete my square, I'm going to complete it in here. So now I'm completing my square. My b value that I'm using to complete the square is going to be 4. So I'm going to be using b equals 4. So I'm going to do 4 over 2 squared, which equals 4. So I'm going to add 4 and subtract 4, and I'm inside of this set of parentheses. So please keep in mind that when we're inside the set of parentheses like this, we still have a 4 on the outside. So I haven't really added 4 and subtracted 4 here. I've really added 16 and subtracted 16. So if I want to pull this value out, which I eventually will, that's what I have to keep in mind. That's the thing that's the hardest part of this problem. So looking at this one here now, I want to get rid of this thing from inside of my parentheses. Keep in mind that this 4 is multiplied, so I really have -16 here. So what I'm going to do is I'm going to move that -16 onto the outside. So as soon as this -4 comes out of the actual parentheses here, I have to remember that I've got a 4 multiplied to it. So again, distributive property throughout this set of parentheses here. So what this is going to turn into, it's going to end up looking like y is equal to 4, and I have my set of parentheses here, x squared plus 4x plus 4. Now on the outside here, I have my minus 16 plus 23. Again, that's the hardest part of this whole problem, is just conceptualizing the fact that we have a 4 on the outside. So when we want to really get this with the other, like 23 is just hanging out, I can't forget to do the distributive property. Then I say, okay, this thing, oops, we already used green, is going to factor nicely. So this is going to be 4, and in parentheses now I have x plus 2 squared. And on the outside here, oopsie, is I just have plus 7. So the negative 16 and the 23 adds up to give me just 7. And now here's my final answer in terms of the equation. And in terms of my vertex, again, it's just going to be hk. H looks opposite the sign here, so this is negative 2. And then here we have 7. Any questions here? Definitely the hardest version of this problem, but still fair game for the exam. Let's look at 29. So here we're going to graph our quadratic inequality. I'm going to do a pretty trashy graph just because I've got some limitations, obviously, but that's all right. So let's look at graphing this thing. So for 29, it's actually kind of a cool problem because this is actually in both standard form and vertex form. So when I don't see an x value and I don't see like in parentheses, and then, it being squared. So like, if I had like x plus 2 and then in parentheses being squared, like nothing like that. This is actually in both my standard and my vertex form. So this is like saying my h value is 0 here. So I'm going to write out the two ways we can think about this. So in standard form, it would be like this. Y is greater than negative 2x squared plus 3, or my a value equals negative 2, my b value equals 0, and then my c value is 3. And then I can also think about this thing as being in vertex form, and that would look like y is greater than negative 2. I'm going to put a x, and I'm just going to put plus 0 here just so people can like see that we've got our h value present. And then we get plus 3. And you could do minus 0 too. It doesn't really matter either way. So now as I'm looking at this thing here, I know my vertex is going to be 0, 3. If I wanted to do my standard form, the way I would set it up is I would do negative b over 2a. And here I end up getting 0 over negative 4, which is just 0. And then I would take the 0 and plug it back in. When I plug in the 0, I would get a 3. So either way you want to start this problem out, we start with our vertex of 0, 3. And then what do we do with it? So at a high level, how is this different than, the graphing equality stuff we've done before? This greater than means I'm strictly going to be above this thing. So the greater than means I'm going to be shading above. And because it is strictly greater than, there's no equal sign underneath it, I'm going to be a dotted line. So again, here we are not actually on the line itself, so this is why we use a dotted line to represent it. So to find these points here, I'm basically going to set up my little t-chart here, which we love so much. Here's my x and my y. I start out with 0, 3, go 1 to the left, 2 to the left, 1 to the right, 2 to the right, and then I'm going to plug in my points. I'll plug in 1 point, and then from here I'm just going to kind of like do the rest out, because at this point we should be able to plug these points in. So if I was doing, I don't know, let's do the top one. So negative 2 times negative 2 squared plus 3. First thing we do is we evaluate our exponent. So here I have -2 times 4 plus 3, which is -8 plus 3, which is -5. So this coordinate point would be -2, -5. Then I'm going to do the same thing plugging in for -1. Ends up just being 1. And then it is reflected symmetrically. So again, this one should match up with that one, and this one should match up with that one. Then I go ahead and make my little pseudo graph here, which is not going to be great, but it's going to be good enough. And we look at this thing and we say, okay, well, what are the points I know? So I know I got 0, 3. So I don't know, I'm going to say it looks like it's about here. And then I go 1, 1. I'm going -1, 1. And I don't know, let's say it's down here and down here. So now the important part here is that I'm dotting this thing and I'm going to shade above. So dotted parabola, and then I want to shade above this thing. So again, for my shading, it should be above. So all of this stuff out here is going to be shaded. Any questions here? Perfect. All right. That is 29. Let's take a peek at 31. Here we are solving quadratic inequality. So the first thing I want to do here is I want to basically solve for where this thing is going to give me zeros. So I'll basically treat this as if it were 2x squared plus 7x plus 2 equals 0. And now from here, I kind of want to look at it for like, I don't know, a fraction of a second. And I want to see, is this going to like factor nicely? Like, can I figure this out, pretty quickly and easily? Or is this going to be something I just want to throw into the quadratic formula? And the odds are, if it's messy and I don't see it immediately, it's going to be a quadratic formula 1. So just to like show you an example here, like with the 30, this being 1 is my easy factoring. -4, so factors for -4 could be -4 and then a +1, because I know they're different, and the larger one's going to be negative, and that would add up to give me my -3. So this is easy to solve by factoring. This one here, I would just divide both sides by 9 and then take the square root. So that one's easy by taking roots. And this one maybe looks a little bit messier. Maybe there's a way that I can do the hard factoring, but I hate the hard factoring. I don't feel like doing it. So let's just do quadratic formula. So here my b value is -7. Oopsie, that's +7. Why did I write a positive? That's silly. All right, b value is 7. A value is 2. C value is 2. So now we're doing the whole -b plus or minus root b squared minus 4ac. So I'm going to say I get -7 plus or minus the square root of 49 minus 4 times 2 times 2, all divided by 2a, which is 2 times 2. So here's just the 7 squared. I don't know why I wrote it as 49 instead. I guess I should, for instructive purposes, write it as 7 squared. There. So now as I look at each of these elements, I'm just going to simplify a little bit. So this thing turns into -7 plus or minus square root of 49 minus 16. And that thing's all going to be divided by 4. And so we're going to simplify a little bit to just call it -7 plus or minus square root of 33 over 4. There's no simplifying the square root of 33, so we're pretty much just going to leave it as is. So what this means is that this is my 0 for this function, so definitely a messy answer here, and that's okay. Quadratic means the equation has a 2 in its degree, so the degree of the equation is 2. The question was, what does quadratic mean? So for all of our quadratic stuff, it's a second degree function. So let's look at a number line here. And again, it really doesn't matter like what the spacing on this thing is. So here I've got -7 minus root 33 over 4. Here I have -7 plus root 33 over 4, and I'm just going to pick a value. So you can approximate like what this thing is. So like -7, this is like approximately, you know, 5 and some change. So it's between 25 and 36. So imagine like we have -7 minus 5 give us, you know, approximately -12 something divided by 4 is going to be -3 something. So this is like approximately -3 something, and here we're adding the 5 whatever and dividing by 4, so it's like -1/2 whatever. So here we're just picking a value. Really easy value to pick is just something which is like absurdly large. So I can just choose 100. So if I wanted to pick 100 and plug that in, I'm just going to see if it works. So now I'm plugging this 100 into my equation. If it works, I'm going to be shading on the outside, and if it doesn't work, I'll shade in between these two things. So that's, again, my goal here. So for 31, let's look at actually plugging this thing in. So here I have 2 times 100 squared plus 7 times 100 plus 2 greater than or equal to 0. That's what I'm trying to figure out. So last time I checked, this is definitely going to be bigger than 0. So we get a check here. So yes here means it's also going to work over here. And if you want to plug in -100, you'd see that it works as well. Basically what's happening is the -100 gets squared. So we'd still end up getting 20,000, and we'll just have 20,000 minus 700, but still, again, much greater than 0. So it works here, it works here. And if we plugged in a value between these two things, we would see that it does not work. So I don't know if you want to plug in like, you know, -2 or -5 or, you know, whatever, somewhere between these two values. And you can use your calculator to approximate those as well. Like you don't need to just be doing it in your head like I was. So my final answer should look like a bolded circle here that's going to be shaded to the left, and then a bolded circle here, which is being shaded to the right. So in terms of actually like solving this thing, what is my answer going to look like? My answer should look like this. So it should look like x is less than or equal to -7 minus root 33 over 4. And I should have another answer, so comma, like something separating them. That I have -7 plus root 33 over 4, and that is less than or equal to x. So again, this, whoopsie, this thing and this thing for my answer here. And I usually separate those with a comma. Any questions on this one? Really messy numbers, but I mean, that's why we have the quadratic formula. So hopefully not too bad to deal with. And again, picking values. If you didn't want to pick 100, you could have picked a value between. If you want to pick a -1,000, you know, whatever you want. It's just got to be within these kind of like regions here. Any questions here? Cool. That one's definitely harder than 32. So if you got that one, then rest easy, as 32 will be a cakewalk. If I had 9x squared equal to, and the reason I was doing a bolded circle is because it's greater than or equal to. So if I had 9x squared equal to 49, the first thing I would do is I would divide both sides by 9. So I get x squared equals 49 over 9. I would go ahead and take my square root of both sides. So I get x equals plus or minus, and this just ends up being 7 over 3. Both of those roots simplify very nicely. Shouldn't it be greater than? Yeah, so the reason that I'm not using the greater than sign right here is because I'm just looking for where the zeros are. And then once I figure out where the zeros are, I then go ahead and plug it in on that little chart, or not a chart, little line graph, and see where the value is going to be. There's other ways of solving this. I just like this method. But I'm intentionally changing this to find where the actual zeros are. Once I know where the zeros are, I can say where it's going to be, because it's either going to be between them or outside of them. Good question. Let's set up our little line here. One of them is going to be a negative 7/3. The other one's going to be a positive 7/3. I just want to pick a value which is between them. I love plugging in 0 if I can, so I'm going to plug in 0 into this thing. So if I plugged in 0 is 9 times 0 squared greater than 49? Not the last time I checked. So here this does not work. Nopers. So x here, check here, check here. So what's that going to look like? Should look like an open circle going to the right, and another open circle going to the right, or excuse me, to the left. So in terms of what my actual answer will be, again, I'm saying all these values. So I'm saying x can be less than negative 7/3, and I can also have x is greater than 7/3. So that's what I'm looking for my final answer. Any questions here? Perfect. All right. There is 32, and let's take a peek at 35. Here we are doing for points on a graph. I'm going to write out my standard form. So I've got a x squared plus bx plus c is equal to y. So when I'm plugging this in, I'm going to use this first point, and I'm plugging it in like a times negative 5 squared plus b times negative 5 plus c equals 1. So again, the y value here is 1, x value is negative 5. So here I get 25a minus 5b plus c equals 1. And now here's one of my equations that I'll be using. So the reason I need 3 points is how many variables do I have in this equation? I have 3. I have a, b, and c. So when I'm solving for this thing, if I have 3 equations with 3 variables, I'm able to solve. So the next one I would do, I don't know, we'll say we'll do it in yellow here. So I'm going to do the same setup. So now I've got a. This time we have negative 4 plus b times negative 4. This one should be squared plus c equals negative 2. So I get 16a minus 4b plus c equals negative 2. I now have my second equation here. And the last one we'll do in green. A times 3 squared plus b times 3 plus c equals 5. So now here I get 9a plus 3b plus c equals 5. And now what am I going to do with these things? So I'm going to take them and I'm going to put them into a matrix because I don't particularly love solving 3-variable equations. So what I'm going to do is I'm going to make it look like a 3x4 matrix, and that 3x4 matrix is going to be 25, -5, 1, and 1. Again, if you want to put the little dotted line here, you can to separate those things. Don't really need to. 16, 4, 1, and -2. And then we get 9, 3, 1, 5. And so now I'm going to do my reduced row echelon form, whether you want to use Calculate 84 as the app that I recommended for you guys, or if you want to go do it on the interwebs using any number of matrix solvers, but I found one the other day. Where's the one I found? Here we go. So I'm going to make my thing a 3x4. And now I'm just going to enter in the values that I want, which is 25, -5, 1, 1. You can hit tab too to like scroll through this fairly quickly, excuse me. It's a cool little trick if you guys don't know that about browsers and other things like that. And then make sure you buy one of these shirts. Obviously, I'm sponsored by them, so get a giant animal face shirt. Where's my calculate button? Again, we don't really, this is kind of cool because it's showing the math syntax stuff before it actually translates it. So like scripting language, this is what it would actually look like to have this, which is pretty interesting. So if you guys do like LaTeX or anything like that, Scribtech is like a intro into it. So check that stuff out. And here we go. This is the thing we care about. So let's grab this. I just gotta do my LaTeX Scribtech plug, obviously sponsored by them as well. And now here I get my actual like reduced row echelon form, which tells me what my A, B, and C values are. So I'm going to try and keep the colors the same. We have A is 1/2. If you want to use 0.5, that's kind of messy too. If you want to use 0.5, again, that's fine because it's like an exact decimal. Just make sure we're not rounding and doing that garbage. B value here is 3/2. And then my C value ends up being -4. So for my final answer here, this whole problem, what's it trying to get us to do? It's trying to get us to say y is equal to 1/2 x squared plus 3/2 x minus 4. This equation works for all these points. So again, anytime we're given 3 points, we're able to find our quadratic equation that would fit that, our quadratic function. Any questions on 35? Perfect. All right. Don't forget to like, subscribe, notify, write it on your arm, spray paint it on a bridge, send a little note with your siblings as they go to school so they open it in their backpack, and that's a wrap.